Welcome to Unit 5, Lesson 5, Changes over Rational Intervals Practice Problems. All right, so this table shows the monthly revenue of a business has risen exponentially since it opened an online store. The first thing we're going to do is we're going to write our equation. So when we start with exponential equations, start with writing your equation. This is our A. 72,000 is our A. Now we have to calculate the B. So from 0 to 3 months, it's going to be one jump. And we're going to use that B term. So our B is going to be 90,000 divided by 72,000. So in the table of values, it's always the lower number minus the higher number because you multiply some number. And this number should be bigger than 1. So now that we have our B, let's write our equation. Y equals A, and I'm going to use 72 and not 72,000, but whatever numbers we get, we're going to multiply by 1,000. 1.25 to the X. Now the tricky part here is X equals 3 months. That does not mean 1 month. So now, what do we have to do to make this 1 month? Well, if I divide both sides by 3, X over 3 equals 1 month. Now, here is what I'm going to put into Y equals 72, 1.25 to the X over 3. Or what I could do is put 72 to the 1.25 to the 1/3, and that will give me X for 1 month. So when we have numbers multiplied like 2 over 3, we could separate the top from the bottom like that. Because when we multiply fractions, tops multiply tops and bottoms multiply bottoms. So either one of the equations will work. If I calculate 1.25 to the 1/3, I get a long number, and I'm going to round it to 4 decimal places. Now this equals 72, 1.0772 to the X. I can use either one of the equations. This one, or this one into Y equals. Okay, now this question says, use the growth factor to describe how the monthly revenue is growing each month. So our growth factor for the jump was 1.25 for every 3 months. We took it to the 1/3 power, and we got 1.0772. There's more numbers, but we're just going to do this. We're the cube root of 1.25. It's all the same thing. Now, this is our growth factor. Remember, the growth factor is the B and the exponent. So that we can say to the X power. It's just the B and the exponent. Now, write an equation to represent the revenue as a function of months. So we can write 3 ways. We can write 72 to the 1.25 to the X over 3. We can write 72, 1.25 to the 1/3 power to the X. We can write, 4 ways. 72 to the cube root of 1.25 to the X. Or we can write our calculated root, which is 72 to 1.0772 to the X. And these all give us the revenue for each month. Okay, so now we're going to put this into Y equals. So hit the Y equals button and put 72, 1.25 to the X over 3 into the calculator, his second graph, and now for when X equals 1, that is 1 month. So each 1 in X is 1 month. So when X equals 1, we have 1 month. Y equals whatever. When X equals 4, y equals that. So let's look at our table of values. Okay, looking at problem 2 here. What we have 100 bacteria that will triple every 6 hours. So the first thing we're going to do is we're going to write our equation. Y equals, our start is 100, triple times 3 to the x, where x equals 6 hours. Okay, now we're going to hit second graph and look at what our table of values says. So when x equals 0, no time has elapsed. When x is 1, 6 hours have passed. When x equals 2, 12 hours have passed, and we see the thing says 900, so then A is true. Now, 3 hours. Our next one says 3 hours. We have to go back into our original equation and change it to per hour. So 100 times 3. Now, if I divide it by 6, that gives me 1 hour increments. So change your equation, divide it by 6, go back to y equals, toggle over till you get to 1 hour, and then you will see in 3 hours, you're not at 200. So that's not true. C, 3 hours is 173. So when x is 3, so that's 3 hours from our start, y equals 173.21. So in the first colony, in the first hour, the colony, so yes, this is true. 3 to the 1 out of 6 hours. Yes, D is true. So C was true, D was true. Between 8 and 9 a.m., 1 hour, the factor goes, every 1 hour, it goes 3 to the 1/6. So E is not true. E is not true. Okay, so here we go with 2 points on the graph. So the first thing we're going to do is write our equation, and then we're going to calculate out to 1. So our A is 150. That's the output at 0. Our B is 20250 divided by 150, which gives us 1.35. So our equation is 150 to the 1.35 to the x, where x equals 1/2 of a decade. Now we pop this into the calculator, and since there are 2 jumps, 1 jump here, that's 1, and then another jump to get to 1, all we got to do is look for x equals 2, and we should get an answer that y equals. So the answer is 273.375, but we're dealing with money, so our answer has to be rounded to 2 decimal places. So make sure you remember your rounding rules. Okay, the exponential function is given by 3 to the x. So apparently there's no a, and we're just dealing with 3 to the x power. So now when we say factor increase, what do we multiply by each time? So 3 to the x plus 1 equals 3 to the x times 3 to the 1. So this is our factor increase. We're multiplying by 3 each time. Okay, so by what factor does f increase when the exponent increases by 2? So if our b is 3 to the x and we increase plus 2, and then we get 3 to the x plus 3 squared, we know that 3 squared is 9, so our factor increase is 9. So now, by what factor does f increase when the exponent increases by 1/2? So 3 to the x increased by 1/2, equals 3 to the x times 3 to the 1/2. The root of 3 is our increase. All right, piece of paper has an area of 93.5 square inches. How many times does it need to be cut in half? All right, so now we have our A, which is 93.5 square inches. So 93.5 is our A. It's cut in half. That's our B. Now we have an equation. Put this in the y equals into the calculator, then hit second graph, and run down your table of values. So when x equals 7, y is 0.7305. So that's less than an inch. At 6 is bigger than an inch. At 7 is less. So that's the number we go with. Okay, this is a very important question. The area covered by an invasive tropical plant triples every year. So our original equation is 1, because A is 1. It triples, that's our B. By what factor does the area covered by the plant increase every month? Now, how many months in a year? 12 months in a year. So that means if this is X stands for 1 year, and to get the month, we got to divide by 12. So it's 3x plus 1/12, which equals 3 to the x times 3 to the 1/12. So our factor is 3 to the 1/12, just like the previous problem.